the quadratic formula. Welcome. So, the roots of a quadratic equation. Now, we need to really understand what these words mean. Remember, we did the Kahoot, and we didn't know whether we were finding factors or solutions. If they're looking for roots, we're looking for solutions. Here also, another word for that are zeros. So roots, solutions, zeros, they all mean the same thing. They're a numerical value. So the roots are going to be the values that make this 0. They're going to be the values of x okay? That's what they mean. So the roots of a quadratic equation in the form ax squared plus bx plus c equals 0, very important, equals 0, can sometimes be found by factoring and subsequently solving for the variable. Sometimes. Now, I've given you a whole bunch of homework to do. That's all factoring, and all of them factor. But the truth is, only sometimes will factoring work. The roots of a quadratic equation in the form ax squared plus bx plus cx equals 0 can always, not sometimes, always be found using the quadratic formula. So the quadratic formula works for all trinomials, whereas factoring works for only some. But here's the trade-off. Factoring is faster. Found by factoring. It is faster than the formula. That's why we like to do it. So factoring, we can get it done a lot quicker than having to use the formula. Now you need to memorize the formula. You will not be given a formula sheet or anything. You are in grade 11U. You need to know the quadratic formula. You need to memorize it. It is negative b plus or minus square root b squared minus 4ac all over top of 2a, as long as you are in this form. Ax squared plus bx plus c equals 0. It must be equal to 0. I cannot stress that enough. All right? And if you want your life to be easy, if you don't want to make undue complications for yourselves, I suggest you always rearrange this so that a is greater than 0. In other words, a is positive. I would never, ever in my life try to deal with a quadratic formula and a negative a, because I'd get a negative in the bottom and it's going to mess everything up. You're going to make mistakes all over the place. So this isn't a necessity mathematically. It's a necessity life-wise in terms of getting a right answer. This is a necessity mathematically. It must be equal to 0. You can't be using this unless it's in this form. So a quadratic must be expressed in standard form, and that's what this is called. This is called standard form. Ax squared plus bx plus c equals 0. And we like a to be positive before it can be solved either by factoring or using the quadratic formula. So setting it equal to 0 is just a necessity for anything, whether you're factoring or using the quadratic formula. The quadratic formula sometimes leads to a negative number under the square root sign. Now, I had you watch 3 videos on the weekend. A negative under the square root sign. Your grade 10 teacher used to say, yeah, that's an error, we're not going to do that. They used to say there's no answer. That's not true. Now, if I was teaching grade 10, I would have said the same thing. But you're in grade 11 now, and we're introducing you to a new number. So when this happens, when we get a negative under the square root, what you have is a complex number. And we know complex numbers exist because you watched those videos. And if you didn't, go and watch them. Which means that they're not part of the real number system. Now, the real number system is represented by a fancy R. It's just a fancy R with 2 lines down it. The complex number system is represented by a fancy C with a line through it. And they represent different groups of numbers. But guess what? From now on, in grade 11, it's okay to have an answer that looks like that. It's not a mistake. It's not an error. It means something, and we're going to work with it. Okay? That's really important, okay? Really, really important. So we're going to solve using the quadratic formula. Okay, so very straightforward. We're going to write out what A is. You notice that it equals 0. So A is equal to 9, B is equal to 6, and C is equal to 1. So the formula is x equals negative b, so negative 6, plus or minus square root. 6 squared is 36, minus 4 times A times C. That root sign goes all the way across, and I like to put a little dash on it to show where it stops. All over top of, and that needs to be the entire thing on top. Okay? The entire thing up there. Now on the bottom, it's 2 times A, which is going to be 18. Then I do a little bit more work. That's going to be equal to negative 6 plus or minus square root 36. Now what's 4 times 9? 8, that's 36. Over 18. So this is going to be negative 6 plus or minus square root of 0 over top of 18. Funny looking 8. And that's simply going to be square root of 0 is 0, so it's going to be negative 6 over 18, which last time I checked will reduce to negative 1 over 3. So there is only one root for this quadratic formula, and it is going to be negative 1/3. That's the only value of x that if I plug in here, I'll get 0. Now, you may say to yourself, I don't think that'll give me 0 if I plug it in, so let's find out. So this is negative 1/3 squared. So it's negative 1/3 times negative 1/3, right? So that's going to be 1 over 9. Because a negative times negative is positive, and 3 times 3 is 9. This is going to change into 6 over 3 plus 1. So 9 divided by 9 is 1. 6 divided by 3 is 2 plus 1. And lo and behold, it works. And it's the only value because we got 0 under here. Because of this 0, we didn't plus or minus by anything, did we? We just had negative 6 divided by 18. Okay, that's it. Let's do another one. Should I wait a minute? Nope. Okay. Let's look at the next one. Danger, 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 Will Robinson. It's not equal to 0. That's a bad thing. We need to change it. We have no business doing anything, factoring or using the quadratic formula, unless it's in standard form. Ax squared plus bx plus c, and we like a to be positive. So a is 3, b is 6, and c is negative 20. So using the quadratic formula, x equals the variable. If it was a different variable, I'd put a different variable here. It's negative b plus or minus square root b squared minus 4ac. Make sure that goes all the way across. Make sure that goes all the way across. Over top of 2a, which is 6. So it's x equals -6 plus or minus square root 36. Now, I'm not so good with my times tables, so I'm going to do 4 times 3 times 20, and then I'm going to worry about the sign. It's a negative times a positive times a negative, so it's going to be positive. So that's going to be x equals -6 plus or minus square root 276 over 6. Huh. Well, that's an answer. That's most definitely an answer. That's what we call an exact answer. It may not be in lowest terms yet. I don't know. But I know it's an exact answer. And there's two answers there. You do realize this, right? There are, in fact, two answers here. One is, and the other one is, so there's two answers here. This plus or minus gets broken up into a plus and a minus answer. This one didn't have it because it was plus or minus 0. So, right, that's not going to do anything, right? These are exact answers. If I use my calculator, I can get an approximate answer, 276 square rooted. So that's the square root of 276. I'm going to add -6 to it, and I'm going to divide by 6. And that's going to give me an approximate answer of 1.769. 3 decimal places, why not? And this one down here, 276 square root negative plus -6 divided by 6 is going to give me an approximate answer of -3.769. Now, a couple of things. That symbol means approximate. So that's an approximate sign. Okay? This is the exact answer. This is the approximate answer. And you guys get confused on that because you think that this is more real than this. But the truth is, see this decimal? I rounded it. That's why it's approximate, because I rounded it. I lost some of it. Whereas this is an actual, the whole thing. So these are called the exact answers. These are called the approximate answers. Now, the only thing that I might want to do here is I might want to find out whether or not I'm in lowest mixed form. So what that means is, and you should know what that means because you'd had some homework on that. What that means is there any perfect square in 276? So can I break 276 up into a perfect square times something else? Well, the way to check that is to check out your perfect squares. My perfect squares are 1 squared, which is 1, 2 squared, which is 4, then 9, then 25, then 36, then 40, hold on, 1 squared, 2 squared, 3 squared, 4 squared, 1 squared, 2 squared, 3 squared. Oh, I forgot one. 1, 2, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 13 squared. I wonder what 14 squared is. So I'm looking at this and I'm thinking, does it divide by any of these? I'm going to try to see if it divides by 4. 276 divided by 4. It does. So 276 is 4 times 69. Now, does 69 divide by anything? I wonder if 69 divides by 9. I don't think it does. No, I don't think 69 divides by 3. 23. So this would be 4 times 3 times 23. Now, 23 is a prime number. So it's 4 times 3 times 23, and nothing else will go into 23. 23 is a prime number, if I'm not mistaken. Yeah. So the only perfect square that can come out of here is 4. So that means that this answer really needs to be reduced. So this answer, if I'm going to leave it as my final answer, really should be reduced. I should take out that perfect square of 4. So this should become x equals -6 plus or minus 4 times 69 over 6. The 4 comes out as a 2. X equals -6 plus or minus 2, 69 over 6. And this is where you have to be very careful. Some of you are going to try to divide those two out, and that's wrong. That's the same as doing 5 plus 2 over 5. You know that's wrong. You can't do that. You can't reduce across addition. It has to be 5 times 2 over 5 to be able to reduce. So you can't reduce across the addition and the subtraction. We need to common factor. So it becomes x equals, and I'm going to common factor out let's common factor out a -2. And it's going to leave us with a 3 and a plus or a minus 69 all over top of 6. And we can reduce this because now it is multiplication. X equals -1, 3 plus or minus square root 69 all over top of 3. And that's how we get the final answer there. And this negative you could put inside, and it could look like -3 plus or minus 69 over 3. And that would be fine too. That's a fine answer. In fact, that might be a nicer answer than having the negative on the outside. In fact, I like this one a lot better. But do remember that you can't reduce out those 3's. They stay in there.
So why can't you, why are we not allowed to reduce the 3's?
Well, if you had 5 plus 2 over 5, are you allowed to reduce these 5's?
Oh, okay.
Right? Same idea here, right?
Okay.
Good. Good question. There was another one. What else is out there?
Sorry, that was me, sir. Can we leave the answer how you had it before on the other page, or do we have to reduce it like you just did?
It depends what you're doing with it. Who am I talking to, Olivia?
Yeah.
It depends what you're doing with it. If the question says, state your answer in simplest form, you have to take it to simplest form. This is simplest form, right?
Yeah.
Yeah. So, but if we're just getting if it says get an approximate answer, then we can jump right here, right? We can use our calculator, which is what Denna's asking. Why can't we use a calculator? You can if I'm after an approximate answer. But if I'm after an exact answer, then you got to either leave it in this form, and yeah, sometimes that's fine. But sometimes if you leave your answer like this and you check the back of the book and the back of the book is this, should you be having a stress attack saying that you're getting it wrong, or should you be able to work your way through that and figure out that they're the same?
Work my way through it?
Yeah.
Okay, thanks, sir.
No problem. Haley, you had a question. Hallie.
No, I think you answered it. I'm just confused still, why we're distributing, because I thought, or that's not factored, so you distribute it because it's not in factored form.
What are we talking about? Why I distributed the -1?
Yeah.
Okay. So let's go through this one more time. And that's a great question, Hallie. You're right on the money there. So everybody, let's pay attention. Let's go over this one more time. You have great questions. Let's answer them well. So we do the quadratic formula, and you come up with an answer that looks like this. Okay? Everybody's cool? We come up with an answer that looks like that using the quadratic formula. We can all do that. I think that's pretty easy for all of us. Now in grade 10, you got to use your calculator and just get a decimal. And sometimes you can do that in grade 11 if they ask for an approximate answer. But sometimes they want an exact answer. This will give you an exact answer, but it's not in lowest mixed form. It's not in lowest mixed form. We know better. We know that this could be changed into we know that. And we know that this is a perfect square. So we want to do this. Now, there's a negative here. I originally common factored out a negative. I'm not going to this time because I like what it looks like without common factoring out the negative. I'm going to leave the negative here. So what am I going to common factor out of the top? What do they have in common? This one has a multiple of 2, and this one has a multiple of 2. So I'm going to take a 2 out. It's going to leave me with negative 3 plus or minus root 69 over 6. This 2 and this 6 will reduce because it's multiplication here, leaving you with a final answer of now that is in lowest mixed form. There's 2 answers here. One of them is this, and the other one is this. If I use my calculator, it'll be 69 square rooted plus, so it's positive, negative 3 equals, divided by 3 equals, and I get an answer of 1.769. If I use my calculator here, I get 69 square rooted. I make it negative. You got to learn how to use your calculator, and each one's different. I'm going to add negative 3 to it, equals, divided by 3, and I get negative 3.769. Those are the 2 answers that I got before. The only difference is this was not in lowest mixed form, and this is. So now you're going to ask me, do we have to put it in lowest mixed form? And I'm going to say, yeah, because that's part of grade 11, is knowing how to do that. You're then going to say to me, well, what's the point? And I'm going to say, you're right. But would you want me to leave an answer for you that looked like this? Would you want me to leave an answer that looked like that? Or would you want that answer to be 4? And would you want me to leave an answer that looked like that? Or would you want that answer to be 4 over 3? And I think we all agree that we'd want the simpler of them. And even though it's not simple to get, and I understand, this is simpler than that because it's in lowest mixed form.
That makes sense. I just have one more question.
Yeah.
When, you know how you like got rid of the 2 and it went from a 1 over 3?
Right.
If it wasn't a 1, would you still distribute it out or no?
No, I'd leave it alone. That's right. Yeah, I'd leave it alone. But it would be up to you. It really would. There would be no different. I think this is what you're asking. If it wasn't a 1, so let's make it not a 1. Let's make it a 12 minus 3 plus or minus 69 over, oh, not 12. Here, there. Let's say we had that question. I think this is what you're asking me. We would reduce that, and you would be left with this. And you're asking me, should I leave my answer like that, or should I leave my answer like this? Am I right? Is that your question?
Yeah.
Okay. Ideally, this is most simplified. So, yes, your textbook would put it in this answer. Between you and me working together, I would be perfectly fine with this. But you're quite right. That would be most simplified. So, yes, you would expand it.
Okay, thank you.
No problem. Okay. Let's take a look at a couple others. How about m squared minus 3 equals 0? Well, that doesn't look like a trinomial, but it is. This is in the form am squared plus bm plus c equals 0. The only difference is a is equal to 1, b is equal to 0. This term is not there because that has a coefficient of 0. We could certainly think about this as m squared plus 0m minus 3 equals 0. And that would be fine. And our c would be negative 3. So when I go to use the quadratic formula, it would be m equals, notice it's m and not x, negative b, well, negative b is 0, so it's going to be 0, plus or minus, square root b squared, so that's 0, minus 4ac, all over 2 times 1. So in this case, it's going to be plus or minus root 12 over 2. And that's a fine answer, except it's not in lowest mixed form, is it? This will change to which will change to which the 2 on the bottom and the 2 on the top will reduce because it's multiplication, and it will leave you with plus or minus square root 3. And if we think about this, and if I solve it a different way without using the quadratic formula, but if I just use algebra, look what happens. The 3 goes over to the other side, and I take the square root of both sides. It's plus or minus root 3. And you need to know that we need both the plus and the minus, not just the root 3. That's why in grade 10, we started showing you that a whole bunch of times. When you take the square root, there's 2 answers, the positive and the negative. And we have the positive and the negative here. Back in grade 9, you didn't take the positive and the negative because you were just dealing with Pythagorean theorem, and there's no such thing as a negative length. But we're dealing with quadratics, and we can have negative x values because we're dealing with the positive side of the x-axis and the negative side of the x-axis. So because our answers can have negatives now, we have to take into account the positive and minus. All right, the last one. Any questions on that before I go on? Okay, so the next one, I've got a equals 3, I got b equals 2, and I got c equals 6. So it's going to be x equals minus 2 plus or minus square root. Now, Victor, you said you didn't like the quadratic formula. It's probably because you didn't have a good memory of it. So make sure that you say it out loud each time, and so that you learn it. And don't bother writing it out and then plugging numbers in. Do it straight away. So it's going to be -2 plus or minus 2 squared minus 4ac all over top of 2 times a, which is 6. So it's going to be x equals -2 plus or minus. So that's going to be a 4. And that's going to, now I'm no good with my multiplication, so I'm going to do 4 times 3 times 6. 72. So that's going to be x equals -2 plus or minus 72 minus 4 is going to be -68. That is going to give us a complex number. That doesn't mean that they're hard roots. It means that they don't lie in the number line. That means that the x-intercepts aren't x-intercepts. They don't lie on the x-axis. And I gave you a video that talked to you about that. So 68, I'm wondering if that has a perfect square in it. I'm going to divide it by 4, and it does. It's got 4 and 17. So what this becomes is -2 plus or minus square root 4 times -17 over top of 6. Now that 4 will come out as a 2. So this becomes x equals -2 plus or minus 2 root -17 over 6. I'm going to common factor out the 2. So it's a 2 minus 1 plus or minus root -17 over top of 6. And that 6 and the 2 will reduce to give me a 3. I'm going to come way down here because I ran out of room. And I'm going to say x equals -1 plus or minus root -17 over 3. And that is an answer, people. You don't get rid of it as soon as you see the negative. Those are complex roots, and there's 2 of them. One of them is -1 plus root -17 over 3, and the other one is x -1 minus root -17 over 3. And no, you can't use your calculator to approximate it. There is no approximate. That's the only way that can be written. Now, saying that, it could also be written like this. And I want you to see it, although you're not responsible for it. It could be written like this. And what I is a new number that you'll learn a lot more about later on. But I is equal to the square root of -1. So see how I have a negative in here? If I take the negative out by being the square root of -1, I could replace it with the I. And I can either put the I in behind the square root 17, or I can put the I in front of the square root of 17. Bottom line, this is as far as I expect you to take it. But I don't want you to be surprised if you see some I's. And what that means is they took the -1 out from under the square root sign.
Sir,
Yeah.
I was just gonna ask, why did you put 4x under the square root?
Oh, it's not 4x. I'm sorry. That's 4 times. 4 times negative 17. Would it be better if I did a dot?
Yeah, that's better.
Yeah.
Thanks.
No problem. That's why we come up with the different notations. That's right. No x's. So this is getting interesting. This isn't like grade 10 where they just say, yeah, it's a mistake, move on. No.
Oh, wait, sir, also?
Yeah?
I was just wondering, for the step where it goes x equals -2 plus or minus 2 times the square root of 17, or negative 17,
Yeah.
couldn't you reduce the 2 and the 6, like the 2 with the square root of negative 17? Like, could you do that? Like,
I think so.
Oh, okay.
Okay, you've got the 2 out here. You've got the 2 here, and you got a 6 on the bottom. So we need to common factor a 2 out of this one, common factor a 2 out of this one, and then reduce.
Okay, got it.
Good questions. Not easy stuff, but interesting. So,
Sir,
yeah.
sorry to interrupt, but on the test, like, I understand, like, for the examples, like, you don't put the general formula, like, x equals -b plus or minus. Like, on the test, like, would you want us to put the full formula without numbers first?
Only if you're going to get it wrong. If you're going to get it right, then no.
Okay.
Fair enough?
Yeah, that's fair.
I'm eating my lunch. Sorry if you can hear me chewing. Okay, so if I have 2 solutions using a quadratic formula, do you know what that means? That means that I have 2 x-intercepts. If I have 1 solution, that means that I have 1 x-intercept. And if I have no solutions, that means I have no x-intercepts. So that's how this is relating to the graph. So this one can be factored, and this one can be using the quadratic formula. This one can be factored, and this one can be using the quadratic formula. This one cannot be factored. This one can be found using the quadratic formula. Not all of these can be factored. Not all of these can be factored. All of these can be solved using the quadratic formula. All of these can be solved using the quadratic formula. And all of these can be solved using the quadratic formula. So that's why we need 2 ways to do this. We need factoring because it's faster, but we need the quadratic formula because lots and lots and lots and lots and lots of them don't factor, and you can't solve them using factoring methods. Okay, I think I'm going to stop the video there, and then we'll continue with what we're learning. I just don't want the videos to get too long.